what is the probability of at least one of them? At least one of them have a repeated decimal, right? Not decimal, repeated pin. So again, this is the story, right? The story is this consultant believed that 15% out of everyone, right? 15 or 16% to make it even, right? Roughly 16% of everyone who make the pin, they will make some repeated number, right? Either 2525 or 1212 or 8787, something in that nature, right? So if for instance, if we have 100 people, 16 of them will have a repeated pin, right? So they ask you, if we randomly select 7 people, right? If we randomly select 7 people, what's the probability of at least one of them have the repeated pin? Well, looking at this thing here, what information? Well, we know that we have 7 people. Now, what is the probability, or what are they giving me? Well, do you agree that the probability of one person who have a repeated pin is 0.158? And again, remember, I told you guys that on your homework, if they ask you for decimal, you have to convert your percentage to decimal by moving the decimal place 2 places to the left. If they ask you, if they give you a decimal and they ask you to convert it to percentage, you have to move it 2 places to the right. Okay. So again, in this case, everybody see that the 15.8 convert to decimal to give me 0.158. Now that is for one person. One person, one particular person, the probability of me select one person based on this data, the probability of me select one person and that person have a repeated pin is 0.158. But again, in this problem, how many people am I selecting? Well, I select 7 of them, right? But again, looking at this thing here, this is the repeated pin. What is the probability that that person does not have a repeated pin? Which is, again, we have to know the probability, which is the complement of this thing here, which is 1 minus 1.58 to give you 0.842. So one person, the probability that person does not have a repeated pin is 0.842. And now if I have 7 of them, what do I do? Well, if I have 7 of them, I have to take the 0.842 times itself 7 times, or in this case 0.842, raise it to the 7th power, right? The first person doesn't have a repeated pin, the second doesn't have repeated, the third doesn't have repeated, the 4 does not have repeated, so on and so forth. Which is, if you do this thing here, you have 0.30000. And again, this is the probability. The worst case scenario that you don't want is you select 7 of them and all 7 of them does not have any repeated pin. Meaning their pin is 1, 2, 3, 4, the pin is 5, 9, 2, 1, something that is not in terms of 1, 7, 1, 7 or something in that nature, right? So looking at this thing here, that's for none, right? None of the 7 have repeated pin. So looking at this thing here, how do I find that at least one? Which is, I need to take 1, which is I have to take 1 minus the probability of none, which is, in this case, I have roughly 70%, right? The probability of me get 7 people and at least one of them have a repeated pin is 70% or 0.7, okay? So again, hopefully you guys see the steps, right? Hopefully you guys see the step in terms of, first we have to ask ourselves, what are they giving me? What are they giving to us? And how do we analyze the information that was given to us? So question with this at least one probability here. Any question with this at least one probability? All right. If you don't have question, this is the end of 4.3, ladies and gentlemen. You know, and again, 4.1, 4.2, 4.3, all of them asking you about probability. Okay. So again, you have to know in terms of which probability or which, right? Is it conditional? Is it at least one? Is it the and, or is it the or is it simple? Okay. And if you can figure that out, you are in a good, very good shape. Okay, well, figured out one thing, and then which formula to use is the other one. Okay, so let's take a look at 4.4. And one thing is 4.4 compared to 4.1, 4.2, and 4.3, the calculation is not that bad. Okay, the calculation for 4.4 is very easy because most of all of this calculation are deal with your calculator. And again, I will mention more with your calculator in a bit. But let's take a look at this thing here. In 4.4, we are dealing with counting, right? We are dealing with counting, and it's not just counting number. It's basically how many ways can we perform something, or how many ways can we arrange something, or how many ways we can mix and match something, right? That's the counting number what we're dealing with, or counting that we're dealing with in statistics. So looking at this thing here, there's only 3 items, which is the first item is the fundamental principle of counting. And later on, you will see that there are permutation and there are combination. So looking at this item that we have, which is, again, they ask you this here, which is, what is the fundamental counting principle? Well, fundamental counting principle is this, is basically tell you that if we know that the total of the first group, if we know the total of the first group, and we know the total of the second group, how many ways can we mix and match the total together? Which is, again, all you need to do is take the item, take the 2 total and multiply them. Okay, so this is what they ask you, or this is what they tell you is, for instance, let's say that you go to your favorite restaurant, and this favorite restaurant offer 7 entree and 5 different desserts, right? And again, you go there, you cannot eat all of them at once, right? So the question they ask you is, how many different ways can you order 1 entree and 1 dessert? Right? So looking at this thing here, you have 2 categories. You have an entree category and you have a dessert category. Do we know the total for entree, and do we know the total for the dessert? If you know the total of the M, which is the entree, and the N, which is the dessert, all you need to do is take the 2 numbers and multiply them, which is, in this case, all you have is 7 times 5, which is there are 35 different ways you can order 1 entree and 1 dessert at this restaurant. Okay, and this thing will expand out. Is not just entree, dessert. It can be drink, right? Appetizer, meaning they can add on different category. The only thing you need to ask yourself is, at each category, how many outcome can I have, or not outcome, how many choice can I have to put in there so that I can multiply? Okay, so if we take a look at example 1, this is what they ask you, or this is what they say, right? The license plate in Louisiana for compact car, not the truck is different. For compact car contain 3 letters followed by 3 digits. How many different license plate can be made? Given that you can repeat the letter and the number, okay? So I did not put it here, but assume that you can repeat, meaning your license plate can be AAA111, right? That you can repeat whatever you have here. So looking at this thing here, this is a little bit different. You say, wait a minute, Mr. Tran, earlier you say, dessert and entree, there's only 2. So same idea go. Looking at this thing here, this is what you ask yourself is, how many slots, right? How many slots does this license plate have, right? Do you agree that there are 6 different slots, right? There are 6 different items that I can put in to make a license plate, meaning I can put in 3 letters and 3 numbers, right? So again, looking at this thing here, you can put letter, number, and again, the fundamental counting principle basically tell you to take those items and multiply them. So now let me ask you, for the letter, how many letters can I put here? Well, from A to Z, there are 26 letters I can put here, right? And I can put 26 letters here, I can put 26 letters here, right? And from 0 to 9, how many single digits are there? Which is from 0 to 9, there are 10 single digits, right? Anything after 9 is just the repeated of this thing, which is 10 is the repeat of 1 and 0. That's why we got 10, right? So again, looking at this thing here, as you can see, looking at this, for the letter, I have 26 times 26 times 26. For the number, I have 10 times 10 times 10, which is, like I mentioned, the fundamental counting principle is can expand to how many ever option you have or category you have. In this case, the slot that you have. And once you identify how many category, how many slot at each category or at each slot, how many options can you put in, right? Which is, in this case, if you multiply them out, because all you're doing right here, ladies and gentlemen, is multiplication, okay? All you do is multiply, which is 26 times 26 times 26 times 10 times 10 times 10, meaning Louisiana can generate 17,576,000 different license plates. Okay, so again, that's all that we need to do is ask ourselves how many different slots, and at each slot, how many options can we insert in, or how many different category, and at each category, how many options can we insert in. Okay, so question with this fundamental counting principle or principle of counting. So looking at this thing here, the last 3 items we have is this 3 items, which is the factorial. Unlike the previous problem, where I say that we can repeat the number and repeat it the alphabet, the n factorial is basically tell you we can select the item, but once you select that item is gone. You cannot replace it back. You know, in the sense that n factorial is basically tell you that take n, multiply to 1 less, multiply to 1 less, multiply to 1 less until you multiply to 1. Okay. For instance, if previously, if I say, well, you can only use the number 1 time, right? Between 0 and 9, we have 10 different single digit. And if you can only use 1 at a time and you cannot repeat it, then again, everybody see that you have 10 times 9 times 8, because once you use the number, that number is gone. You have 1 less, 1 less, 1 less. Okay, so that's what factorial is. It's basically tell you to take that number times 1 less until you get to 1. Okay, and 0 factorial is, by definition, 0 factorial is equal to 1. Okay, if you have 0 item, how many choice can you choose? There's one way, which is you choose nothing, because you have nothing to choose. Okay, so here come the problem. Here come your challenge, your objective for today, or objective for 444, is you have to determine which one is a permutation and which one is a combination. Okay, permutation is when the problem tell you that the order matter. If there's some specific order that we need to choose, if there are some ranking, if there's something in terms of the importance of the position, then it's permutation. If they tell you that the order does not matter, then it's a combination. Okay, so if it's very in general, then it's a combination. If in terms of specific, I want it this way, this way, this way, want first, second, third, or in some scheduling that I have to met, then the order matter, then you have to use permutation. Okay, and I don't focus in a lot about the permutation formula and the combination formula. I put it there for you guys because after I mentioned this, you probably won't remember your permutation formula or your combination formula, because your calculator can help you calculate this thing here. Okay, so again, in order for you to use your calculator, this is the option that you need to do, which is you have to select math in your calculator, and on the top you have to scroll over to P or B, which is stand for probability, and then you have option 2, 3, or 4 that you need to choose. And again, once you have that, this is what we have, which is, again, you have to well, this is, I just want to remind you that order matter, and for permutation and combination, the order doesn't matter. Okay, so let's take a look at this thing here. Let's practice this, right? This one is very straightforward, which is they ask you evaluate the following, right? So they ask you to evaluate the following, which is, let's say if we, let me change the set. So let's say if I ask you, or I ask you this on the test, right? So if we were to ask you this on your, if I were to ask you this on the test, which is, again, we have to, so let me clear. So looking at this thing here, if you were to have this question on your tests, and they ask you to calculate or evaluate this 21 factorial. So how do we evaluate this thing here, which is the first thing you need to do is you need to press 21, right? You have 21, and then the math portion is right here, the third button, which is, again, you have to press math. And on top, you have math, you have number, you have CPX, and then you have P or B, which is you have to scroll over to the P or B. And then as you can see, for my 83, I think your 84 is a little bit different. Let me make sure. I think my 83 is the option 1, 2, and 3. Oh, it's the same for you guys. So option 2 is the NPR, option 3 is NCR, and option 4 is the factorial. So everybody see that A, they asked us for 21 factorial. So all we need to do is go in here and choose the factorial, which is, everybody see that 21 factorial. That's what they asked me, is 21 factorial. And all I need to do is press enter, which is they calculate and they give me this item here, which is, again, 5.109094217 e to the 19. One thing I want to point out, ladies and gentlemen, e to the 19 is basically 10 raised to the 19 power. Basically, is tell you how many decimal you need to move to the right. If the 19 is positive, that's how many decimal, which is we have 19 decimal, move it all to the right 19 times. Okay, which is, again, is the number is humongous. Your calculator does not fit. That's why they put to the 19. So on your homework, they will ask you to write in scientific notation. So if you have to write in scientific notation, which is, again, the base is always base 10 raised to the e to whatever this power is. Okay, so base 10 e to the 19. This is where the 19. This is where I got the 19 from. Okay. Everybody see that this is where I got the 19. Okay, so in this case, everybody see where I have 21 factorial, which is, again, 21 factorial is 5.10909 times 10 to the 19 power. If you were to have to do on the B, which is, if you have to do B, which is, this is what you need to do for B, you have to type 17 math, go over to P or B, and go down to NPR, which is number 2, option 2, and then you have to type 9. Everybody see where I have 17 NPR 9. And again, that's what we have, 17 P9, which is, again, the N is the total, the R is how many ways or how many items we need to choose from. Okay, so again, one thing, as you will see later, if you have one big number, one small number, your N will always be a bigger number, because there's no way you can choose 17 items from a group of 9, right? You can only choose 9 items from a group of 17. You cannot choose 17 from a group of 9, okay? So again, your total, your big number will always be first. So make sure that you have to type the first number first, choose the NPR, and then choose 9, which is, everybody see that this is my answer, 8821612800, or in the sense that this is 8,821,612,800 different ways that we can choose. If we have 17 and we choose 9 people, 17 people and choose 9 people, where the order matter. And lastly, if you type in 17 math, P or B, and then NCR, which is combination, and then you press 9, which is, as you can see, we have 24,310. So looking at this thing here, like I mentioned earlier, the calculation should not be, the calculator will do the calculation for you. But the challenge is you have to use the right one. So the most important thing in 4.4 is you have to determine, you have to decide, are you using the NPR or are you using the NCR, which is permutation for the P, which is the order matter, combination for the C, if the order doesn't matter. Before we move to the next problem, question on how to use your calculator, because as you can see, 4.4 is very calculator dependent. Well, most of, as you can see later, is all calculator dependent. Question with this one here. So everybody good with the calculator? All right. I will ask you to, from now on, I will ask you to verify my answer. I won't show you how to type in your calculator. So again, let's take a look at this problem, which is, again, if they give you this question, if they give you this 3 problem on the test, life is too easy, right? If on the quiz or on the homework is too easy, there are some, right? You need to, but this is the question that they ask you, or this is the question that they will tell you is something in this, right? Something in this nature, right? And then, you have to analyze, you have to dissect, analyze your information, see what they give you and see what we need to looking for, right? So let's take a look at this thing here. Let's say playing the horse, right? And again, I just copied this problem from the book. So again, so that I have some problem to talk to you about. In a horse racing, one can make a trifecta bet by specifically or specify in which horse will come first, which horse will come second, and which horse will come in third in a correct order. So in order for you to win this bet, in order for you to win a trifecta, they have to come exactly the exact order, right? A correct order, okay? Which is, again, the horse that you choose come first have to come first, the horse you choose come second have to come second, and the horse come in third have to come in third in a correct order, okay? The other one, which is one can make a box trifecta by betting a specifically or specific, which 3 horse will come in first, second, and third without, right? Without the specific order, right? So looking at this thing here, everybody see that for a trifecta, the order matter, right? Because they have to have exactly first, second, and third. Meaning that is your imitation. For a
class is almost finished.
Question? So for this thing here, for this box trifecta, the order doesn't matter, right? So again, sometimes that's what you need to ask yourself, right? Sometimes that's what you need to ask yourself is, which one am I using? And if you recognize that this is the order matter, and that's where you use the permutation. If the order does not matter, that's where you use a combination. So now, once you identify which one is permutation, which one combination, the second thing you need to ask yourself is, now, what is my total and how many am I choosing from the total? So for number 1, they say in a 10 horse field. So in a 10 horse field, meaning everybody see that we have 10 horse in the field, right? So again, meaning there are 10 horse in this race. How many different ways can you bet a trifecta? Which is, again, how many different ways can you choose the first horse, the second horse, and the third horse where the order matter? So given this item, which is, again, as you can see, we know that the n is equal to 10 because there are 10 horse in this field, or 10 horse field, right? And how many are we choosing? Which is the or we choosing 3. first, second, and third place, right? And now looking at this thing here, because the trifecta, they told us that the order, specific order matter, right? And because the specific order matter, meaning we have to use the permutation, and the permutation tell us that we have 10p3. And again, 10p3, you use your calculator, you type 10, you choose the NPR, and you type in 3, you should have 720, okay? And again, the box trifecta, the order does not matter. And the order does not matter, as you can see, we use a combination. And the combination, we have 10C3, which is in this case, 10C3, we have 120. So looking at this thing here, like I mentioned, hopefully you guys see that the calculation is very doable. The hardest part is which formula are we using, okay? If you can recognize, if you can analyze, if you can simplify, well, not simplify, but dissect your information and know which one the order matter and which one the order doesn't matter, then this problem will be very doable, okay? Let's take a look at the next problem, and then I will see if you guys have questions, because this one here, and again, I agree. I some students don't know what the trifecta or box trifecta is. It's just the horse racing language, So let's take a look at this thing here, which is, let's say if some problem they clearly state something like this, right? Let's say that this is kind of like a open item, which is they ask you this: a certain ice cream parlor offer 15 flavor of ice cream. You want an ice cream cone with 4 scoops of ice cream, all different flavor, right? In how many ways can you choose a cone if the order of the flavor doesn't matter to you? Right? So again, looking at this thing here, clearly, as you can see, when you see this thing here, you can say, oh, the order doesn't matter, right? The order doesn't matter, tell me that I have to use a combination, right? And again, if the order matter, we have to use permutation. Everybody see that? So that's the one thing in 4.4, you have to ask yourself, does the order matter? Which is in this case, the order doesn't matter. So I have to use a combination. So in this case, how many flavor do I have? Which is, do you agree that there are 15 flavor? And out of that 15 flavor, how many am I choosing, or how many are you choosing? You're choosing 4, which is, everybody see that we have 15 C4. And why C? Because the order does not matter. So 15C4, if you use your calculator, you have 1,356 different way, okay? And number 2, they ask you, in how many ways can you choose a cone if it matter which flavor on top, which flavor in the middle, and which flavor in the bottom? Meaning there are specific flavor you want first, second, third, and fourth. Everybody see that? And because there are specific order that you want it, everybody see that this one here is a permutation problem. We have 15P4, which is 15 choosing 4. And again, 15P4, you will have 32,760. So again, hopefully you guys see that this problem, and again, this is your typical problem, you have to know which one, like I mentioned, the hardest part is which one is a combination and which one is permutation. Again, the order matter, permutation. The order does not matter, combination, okay? Question with number 1 or number 2 here. Everybody good? All right, let's challenge you guys a little bit more, right? Probably guess I can stop here after this question and then see if you guys have questions. But again, let's take a look at this thing here, which is again, so similarly, they give you this information, right? As you can see, this problem and the previous problem is pretty much identical, right? Why am I saying identical? The story it's different, but the number is the same, right? Everybody see that this one here, last time is your ice cream flavor and you choosing four flavor, right? This one here, they say that the student counselor at a certain school have 15 member, right? There are 15 member, last time we have 15 flavor. 4 member will be formed. Last time 4 flavor are chosen, right? So 4 member, which is we have 15 choosing 4. Everybody see that the problem is the same, right? The number is the same, I should say, right? Will we form for executive committee consider of a president, a vice president, a secretary, and a treasurer. In how many ways can this 4 position be filled? So one thing is, again, if you look at this thing, well, let's take a look at number 2. In how many ways can 4 people be chosen for the executive committee if it does not matter? Well, looking at this thing here, well, we can draw a conclusion that if this does not matter who hold which position, right? Doesn't matter who hold which position. Everybody see that number 2 is a combination problem, okay? And you probably say, well, Mr. Tran, on number 1, they did not tell me anything in term of specific, right? But do you agree that they all give you specific title here? We have a president, a vice president, a secretary, and the treasurer, in terms that there are some ranking, right? That's why I mentioned last time, the order, the ranking, and the specific title. Those are the 3 items that tell you that you need to use permutation. In this case, they ask you the 4 position, which is the president, the vice president, the secretary, and the treasurer to be filled, which is in this case, everybody see that because they give us a ranking here, we have to use permutation. So again, looking at this thing here, we have 15P4, which is the same as before, which is 15P4, I think it's like 32,760, right? That is how many ways we can choose 4 people from a group of 15 people where the specific ranking matter or specific order matter, okay? And number 2, we have 15C4, which is previously we did this, which is 1,365. And again, this is where the position does not matter, okay? So here comes the problem, ladies and gentlemen. It's not the permutation, it's not the combination, is they put everything in chapter 4 together, right? What does that mean? That means they put the probability with the permutation and with the combination. So they ask you this question here. They ask you 4 of the people on this counselor are Sam, Justin, Brittany, and Rashid, right? What is the probability that Sam is the president, Brittany is the vice president, Justin is a secretary, and Rashid is a treasurer? So looking at this thing here, do you agree that they give us a specific person for a specific position, right? They give us that Sam got to be president, Brittany got to be vice, Justin got to be a secretary, and Rashid is got to be a treasurer. So looking at this thing here, how many ways can these 4 people fit this 4 position? Everybody see that there is only one way, right? Brittany cannot be anything beside president, vice president. Justin cannot hold any other position besides secretary, meaning there's only one specific way that this have to meet, which is, again, they ask us, as you can see, they ask us probability. How do we find probability? Is what we're looking for, which is this one specific way over the total way that we can choose 4 people where the order does not matter. So in this case, hopefully this is what you have, ladies and gentlemen. I want to point out that, again, first of all, on your homework, depend on your homework question, they might ask you to give them a scientific notation. And if a scientific notation, you have to put whatever the number times 10 to the whatever the E is. If you type in your calculator have the E -5. The E -5 tell you is basically take this decimal and move 5 places to the left. Because of a negative, you move it to the left. If it's positive, you move it to the right. So everybody see that the decimal is between the 3 and the 0 right here. I move 1 place, 2 place, 3 place, 4 place, 5 place. That's what the -5 come in. Okay, so be careful on your homework so that you know that you need to know which answer you need to type in for your quiz and know which answer you need to type in for your test. So everybody see the difference between the scientific notation here versus the decimal here. So again, -5 tell you move 5 places to the left. Okay, and again, this is what we have. Why do I have 1? Because there's only one way that these 4 people fill in this 4 position. Okay, and again, out of the total ways that I can choose where the order matter, which is out of that total. And similarly, this is what they ask you: what is the probability that Sam, Justin, Brittany, and Rashid are the 4 commissioner? Looking at this thing here, again, how many ways can this 4 be elected? Well, still, there's only one way, right? Meaning, again, we have 15. They might have Jennifer, they might have James, they may have whoever. But we only need these 4 people, which is there's only one way that these 4 people be selected. But they say that, again, do they give you specific title for each of them to hold? They don't, right? They generalize. They say, oh, I just want these 4 people. Doesn't matter which position they have, which is the order doesn't matter. So to find the probability, we have to take 1 divided by 1365, which is the probability of this 4 got elected is 0.007326. Okay. So again, make sure that you identify the difference between the exponent in terms of the scientific notation versus the decimal here. So this is where we heading, ladies and gentlemen. This is where we heading. Hopefully you guys see that the permutation versus the combination is easy to identify. The second thing that you would see that what we need to do is we need to identify, once we find out the combination and permutation, they will add on top of that, what is the probability of this or what's the probability of that, okay? So looking at this thing here, looking at this item here, question on this 4 item, 1, 2, 3, and 4 here. Well, if